What's up guys, welcome back to my C# series. Today we're gonna be talking about two major topics: the difference between the value and the reference types and the nullable type, because I feel that both these topics are issues that have been circulating for a really long time among junior programmers, and I feel like more and more people are kind of a little bit confused about what these mean, and that there should be a little more awareness, at least towards the value reference concept, which is very important to know, like what it means, where you should be concerned about it, and what the right choice kind of is when it comes to them. The main problem with the concept of value and reference type is that it has to be explained in a rather two-stage way. On one hand, it is important to understand as early as possible the difference between the two, because it helps you in the long run to understand some fundamental concepts of programming. On the other hand, this is a rather advanced topic which relies on many concepts I didn't teach you about yet, like the stack and the heap memories, classes, instantiation, garbage collection, and others. So for now, I will give just a vague general idea about this subject, explaining them more in a future lesson. First, I will explain at a very basic level how RAM memory is organized inside a computer. There are multiple areas inside the RAM, but programmers are usually interested in only two regions, stack and heap. Stack is the memory area where value types are always stored. Whenever you declare a value type variable, the value that variable contains is stored directly inside the stack at some memory address. However, when you declare a reference type, the value is stored on a heap, and on the stack is stored the address location where that value is stored inside a heap. So, when you declare a reference type variable, the variable actually holds an address to some other memory location that contains the value, and not the value itself. In some future lessons, we will learn that multiple reference type variables can point to the same heap memory address. This means that a value stored on a heap can be altered by multiple variables that all point to its address on the stack. So, the concept of value type is rather easy. Value types are data types that hold the value within their own memory space, or in other words, they directly contain their values. You can think of it like holding something in your hand. If your hand was the RAM memory, whatever you hold in it is directly contained there, in the palm of your hand. Reference types, on the other side, don't store values directly. Instead, they store the address of the memory location where the data is actually stored. This can also be described as containing a pointer to another memory location that holds the data. You can associate this concept with holding a GPS in your hand. You do not hold the place where you want to go in your hand, you hold a device that points to the location where you want to go. Similar to not holding a value but a pointer to the location where that value is actually located. Because value types are storing their value directly in the memory location, whenever you use this kind of data types, the system will actually use a copy of that value. Opposite of this, when you use reference types because they point to a memory location, you are not actually using the data itself, but a pointer to that location. This means that the value is not copied for each instance that points to it, but it's directly used by all of them and can be altered by all of them. Value types are bool, byte, char, decimal, double, enum, float, int, long, sbyte, short, struct, uint, ulong, ushort. Reference types are strings, arrays, tuples, lists, dictionaries, sets, stacks, queues, classes, interfaces, pointers. For your beginner level, since we haven't yet learned about many of these types, you only have to remember that the types we learned in the last lesson are all except string, value types. Another difference between value and reference types is that reference types can have a null value, or in other words, their stack value can be empty or point to no address on the heap. Value types must always contain a value. There is something in between value and reference types, namely, value types can be made to store a null value called nullable types. This is the usual way in which we declare a value type, let's say an int. Now we can declare a nullable int either like this or like this. Both of the above declaration are equivalent. You can use nullable variables whenever you need optional data. For instance, you may want to store data about your employees, but age is an optional data field. Since int doesn't allow storing null values out of the box, you can use a nullable int instead. We are done for this lesson. Thank you for watching and see you in the next clip where we will discuss the escape sequences. Bye!